Assalamu alaikum everyone. This is Probability and Statistics for Engineer course in the Department of Civil Engineering, International Islamic University. Today our topic is data representation in statistics. We have already covered some basics related to probability, and we have already discussed probability distribution, but now in this lecture and lectures that I'm going to deliver later, we will be dealing with some statistical terms. So you need to know that how to represent different data. If we collect the data from the field, then what are the ways to represent that in statistically, in a tabular form or in a visual form, in the form of graphs. So it's not necessary that every time we receive a same kind of data. So we do have different kinds of data. So we will talk about different types of data here, and then we will discuss how to represent that data graphically. So let's start for today's lecture. Now, as I said, we have different type of data. So data is basically transformed or basically categorized in two different types. One is categorical data, and another one is numerical data. So if we have a data that is in a string form, normally in programming language we call it string. For example, we have a data like male or female. So M and F. If we say that in one city there is 1 million male population and 2 million or 1.5 million female population, so dividing this is a categorical data, or we can say that are you a registered voter. So if you say are you a registered voter, yes or no will be the answer for that. So the data in the form of yes or no is also categorical data. Similarly, eye color for anyone, if we say the eye color is blue or eye color is black, so this is also a categorical data. In fact, these data are defined in categories. So the data defined in the form of group or category is categorical data. And another kind is numerical data. So numerical data is then further divided into discrete and continuous data. As I have already mentioned about discrete random variable and continuous random variable. So we usually have in the numerical data we have discrete data and continuous data. For example, number of children might be 4, might be 2, might be 5. So this is a numeric value. We can't say 1.5 children. And defects per hour, for example, there are 25 defective parts of a machinery in an industry. So these are all countable parts. So we can say this is discrete data. Similarly, weight, a person having weight of 70.5 kg are having weight 65.4 kg. So this is a continuous data. And similarly, a voltage we usually measure as a continuous data. Okay, so how to present this data, how to represent these data in statistic. Normally when we collect the data, it's in a raw form. So we sort it out, this data, and then present it in such a way that it become easier for user, or it become easy for the reader to understand or extract some meaningful information from that data. So we can either arrange the data in the form of table, or we can arrange in the form of graph. For researchers, for teacher, for students, for anyone who has a data, and they can either present that in the form of table or present that in the form of graph. So also the type of graph, then there are different type of graph that we will also talk about these graphs. So these graphs are also based on the type of variable or type of data being used. Now graphical representation of data. If we represent data in the form of graph, as we have said that we have, as I have mentioned, that we have two different type of data. One is categorical data and another one is numerical data. So categorical data is represented by a frequency distribution diagram, bar chart, pie graph, and Pareto diagram. We have different diagrams on the basis of which we present these categorical variable. Similarly, numerical variable are represented by line charts. These are very basic one. Line charts are very basic to represent numerical variable. Frequency distributions, these are like probability distributions. If we transform the frequency to relative frequency and then we plot that, then it gives us probability distribution diagram or relative frequency distribution diagram. We will talk about later when we discuss normal distribution. Histogram, in fact, histogram is then developed from frequency distribution diagram, and if we take the cumulative of that, we can also obtain gives from that. And scatter plot is a very initial check to determine the relationship between two variables. We will also discuss about that later. Okay, so as I said, categorical data can be explained in the graphical form as well as in the tabulation, in the tabular form. So we have frequency distribution table. In the graphical form we have bar charts, pie charts, and Pareto diagram. Okay, let's talk about frequency distribution table. So if we take an example of hospitals patient by unit, we have different units in hospital, that is cardiac care, emergency unit, intensive care unit, maternity unit, and surgery unit. And we obtain the data from that hospital, and then we see that we have 1052 patients in cardiac care, and then emergency, then intensive care, then maternity, and surgery. So the best way is to represent that in the form of frequency distribution diagram. So we have number of patients and we have categories for hospital units. So variable are categorical. Here the variables are categorical. Now bar chart and pie charts are another way of representing that data. So if we have data that is qualitative data or category data, as we have in a previous example, so we can also develop a frequency distribution diagram, or we can determine the bar graph, as well as we can make a pie chart of that. Now height of bar or size of pie slice. In case of bar diagram, the height of bar, or in case of pie diagram, the size of pie slice show the frequency or the percentage for each category. So if we have a frequency value, we can transform that into percentage, or we can also transform that into its probability value. Now you can see here that in case of bar chart, if we have considering the same example and showing the hospital unit, these are categories on x-axis, and the respective number, let's say for the cardiac care, that is 1052. So cardiac care 1052 is represented here. So this is bar diagram, this is a filled shape, and this show the amount of patient, a number of patient in the cardiac care unit. Similarly for emergency, that is 2245, and that is represented by another bar. So this is a very simple way to represent the data in graphical form. So as we can see here, we have a lot of patients in a surgery department, so we can see the bar of height greater in case of surgery. Now pie chart is also for representing the qualitative data. So in case of a hospital unit, as I have mentioned, different categories. So for different categories we have a respective number of patients, and what we do, we sum up all these patients and divide each by the total sum. For example, if for the cardiac care we have 1052 patients, and then we divide 1052 by total number of patients in that hospital and multiply by 100, so that will give us the percentage. So for all these, we will receive the respective percentage, and when we sum up, then that will be equal to 100%. So as we have a circle, pie chart is basically a circle. So what we do, we have about 53% or 52. Okay, one thing more, if you have the percentages in decimal, then transform that to rounded to the nearest percentage. So 52.5 will be transformed or converted to 53%. And what we do, we divide this whole circle into respective percentages. As we have this equal to 360 degree, so we take the 53% of that 360 degree, and that will give us 1 degree value. And what basically we do, we convert that to 53, and then this 53 is represented in 360 degree. So in 360 degree, and this whole portion is representing the surgery. And for case of cardiac care, which is 12%, so 12% is converted, so we take 12% of the 360 degree, and then we plot that as well. So similarly we plot other one. So the portion with which take more part in that pie chart means it has more percentage. Now there is another plot, that is Pareto plot. In Pareto plot, that is similar to the that is similar to the bar graph, but in that way, in that Pareto diagram, what we do, we arrange these categories in descending order of frequency. So it will be, for example, we have a category with the high percentage. We start, if we start from the left side, so we plot it, then we plot another one on the basis of its frequency, then we plot the third one on the basis of frequency, then fourth one on the basis of frequency. So it's like a bar graph, but the data is arranged in categories. Now in case of the Pareto chart, we if we go toward advanced analysis, then we can also separate the data from significant data from insignificant data, or in fact not the data but the factors, significant factors from insignificant factor. We can say that first two factors with the higher frequency are basically the significant factors, and the remaining two are insignificant factors. So we can make a threshold of that. Now let's see an example related to Pareto diagram. We have 400 defective items that are example for the cause of defects, and there are different type of defect in case of manufacturing. So that might be bad welding is bad that might have poor alignment, that might have some of the items might have missing parts, paint flaw, the paint is not proper, electric shorts, electrically that is not properly insulated, there might be some cases that are cracked. So if we examine all these parts, we out of 400 we see that we have bad welded part that are 34, poor alignment parts are 223, and similarly all other. So as we can see here, if we calculate the total percentage, so for example for number 1, the percentage will be 34 divided by 400 multiplied by 100, and that will give us the respective percentage for bad weld. Similarly for poor alignment and missing part and all other. Now what we do, sort by defect cause in descending order. For example, we can see from the last one that the poor alignment has more number of defects, which is followed by paint flaws. So we arrange that in descending order. The first one is poor alignment, the second one is paint flaw, the third one is bad weld. So we can see here that the number of items are decreasing downward, so as it is arranged in a sorted form. So converting these items number into percentages will give us the respective percentage for each item. And then what we do, plot the same bar graph, but we can see here that the leftmost column with the bar of poor alignment has higher percentages, which is then followed by paint flaw, which is then followed by a bad weld. Now on the left side, that is on y-axis, we see the percentages. So if we determine the cumulative percentages, that is, if we add all them from left toward right, so we get another graph, and that is the cumulative one, that is the cumulative graph, and that will sum up to 100%. Okay, so I will stop it here. I will not go more into detail because we have to make a short videos for easy uploading as well as for downloading. So in the next lecture, then I will talk about time series diagram and some more diagrams. So these are different type of ways for representing for presenting the data. If you perform an experiment, or if you are doing a project and you obtain the data from the field in the raw form, you can arrange that, and then you can graphically represent that to get initial guess about its trend, and then you can perform some statistical analysis later. So thank you for now.